Okay, so let's start with a more difficult, not difficult, but little difficulty level we are increasing from one spring we have now to a spring. So let's say we want to have two springs in combination and we want to solve this kind of problem. So now in this case we will have three nodes. Yeah, let's call it number 1, number 2 and number 3. U1 corresponds to node 1, then you have U2 corresponding to node 2 and then you have U3 which corresponds to node number 3. Okay. Now we can write equation for the two springs separately and then we can combine them together. Let us see what happens. So let us say this is K1, this is K2. Okay, so K1 spring constant, K2 for this one. Node number 1 and 2, and for the second one it is 2 and 3. Let us call it element number 1, this is element number 2. Yeah. So this is element number 1, element number 2. Yeah, and node number we have this node number 1, node number 2. We are using the global numbering system only. So meaning that whatever we wrote here, we are just writing same thing here, right? So 2 here, so 2 here, 3 here, so 3 here, this 2 here is this 2 here, right? Okay. So now for the first element, okay, we can write the equation, and the equation is K1 right minus K2, sorry, not K2, it should be K1 only. So we have minus K1, then we have minus K1 here as well, and then K1, and we are going to multiply it by U1, U2 is equal to, and F1, F2, F3, F1 and F2. We have to write here, actually there is a displacement as well. So here we have force as well. So we have F1 here, then we have F2 here, and then we have F3 here. So the all forces should also be written. Yeah. Okay. So this is what we get from this one. Okay, and from the second one, from the second one also we can write, and that will be like this. It will be K2 minus K2 minus K2 K2, and then we have U2 U3 is equal to, we have F2 and F3. Yeah. Okay. Now here we have to be careful. Okay. Why careful? See here, F1, of course we have F1, there is no other element this side, so F1 we can write like this one. F2 actually is shared, right? So this side also there will be something, this side also there will be something. Instead of writing F21, we have to write differently. We can write F2 of 1. So we can write F21 like this one. Here we write F22 like this one. Yeah, so that, so we write F21 here and this write F22 here. So that here that really means we have displacements which is U2 and U3. Whatever displacement is here for element 1, same displacement will be reflected here, because they are, both of them are connected together, and hence U2 if u2 is here, this will be also u2, but forces inside this and inside this may not be the same. Hence, we have to write differently. So, we write in this case here the force, let us say this is F21, okay, and this we are calling it F22, yeah, and here F3, and here it is F1, yeah. So, now these two equation, if we combine together, then what happens? Okay. So, what we have to do is we expand this, right. You can expand this equation, these two equations, then expand these two equations, and we have to write such a way that we can combine this. Instead of saying u1, u2, u2 with u3, we write u1, u2 and u3, and then we will see what we can write this side, what we can write that side, yeah. Okay. So, let us, what you have to do is we have to write, so we have to write u1, u2, u3 is equal to, there will be something here and there will be a 1 3 by 3 matrix here by that. How? By combining these two, right. How will we combine? So, for u1 we have u1, u2 and u3. So, u1 first equation, if you see u1 multiplies to k1, yeah. So, we go here u1 multiplies to k1. So, we just write k1 here, k1 here, okay. Now, let us go back. Then we have the first equation, k1 multiplied to u1. So, I have written k2 k1 already, then minus k1 multiplies to u2. So, okay. So, we will go back and we write minus k1 here, okay. Then if you see here with u3 nothing is being multiplied here, yeah. So, that means coefficient of u3 will be 0. So, we can write this as 0, right. So, and here we have f1. So, accordingly we will write f1 here. So, first row is complete, okay. Similarly, we will complete the last row because that is convenient, okay. So, let us see here, last row is nothing but we are going to write this equation, okay, this equation, okay. So, meaning that minus k2 multiplied by u2 plus k2 multiplied by u3 is equal to f3, that is what we are going to write. What is the coefficient of u1 here? u1 does not appear in this line, right. So, the idea is to have write this equation first, okay, and then combine these two equations, right, and then we have this equation, the last one. So, I am writing the last one. So, last one is there is no coefficient for u1 here, right. So, we will write 0. So, we will have 0, yeah. Then the coefficient of u2 is minus k2. So, we write minus k2 here, minus k2. Then coefficient of u3 is k2, yeah. So, we will write k2 here, right. So, this is done, okay. So, and here what you have, is F3. So, we write F3. Okay. Last row is finished, only remaining is this one, we have to fill it here. And how? It will be some, we have to write some here which multiplies by u1, then write here which multiplies with this, and some value which to this one, and here we will get something. What we will get? Okay. Let us see what it will be, automatically we will know. Okay. So, now second one, we are going to, we will combine total 4 equation here, right. So, one equation is this multiplied by this equal to this, second equation is this multiplied by this equal to this, third equation is this multiplied by this equal to this, and fourth equation is this row multiplied by this column equal to this one. Now, we have written the first one, this multiplied by this equal to this as the first row, then we have written this multiplied by this equal to this as the last row. Now, we are going to add this multiplied by this equal to this, and this multiplied by this equal to this, we are going to just add them together and write on the next page. So, if we have this multiplied by this equal to this plus this multiplied by this equal to this one, then what we get is we are adding them. So, this plus this is the addition simply, right, F21 plus F22. So, let us write that first. Okay. So, we have F21 plus F22. Yeah. Okay. Now, in this excuse me. So, in these two equations, this multiplied by this and this multiplied by this, only minus k is the coefficient of u1, right. So, u1 is only here only, that means it is going to be multiplied by this one. So, minus k1 is the coefficient of u1. So, we will write minus k1 as the first entry. So, we will write here minus k1. Okay. Next, now coefficient of u3 easy to know, hence I am writing that first. So, u1 is here, u2 is here, u2 is here, u3 is here, and we are considering just this multiplied by this equal to this and this multiplied by this equal to this only. Hence, u3 is here, which is going to be multiplied by minus k2. Yeah. So, coefficient, what do we have? We will have this minus k2 multiplied by u2 plus k2 multiplied by u3 equal to f3. This is the last line, right. So, the last row, if you see, should be equal to f3, whatever equation gives u equal to f3, that we have to write, right. And coming back here, what we see here, f3 is here only, and that the equation is minus k2 multiplied by u1 plus k2 multiplied by u3 equal to f3. Hence, this is what we have to write, right. So, that means as far as f3 is concerned, there is no coefficient of if you there is no coefficient of u1, right. So, coefficient of u1 equal to 0, because last equation is minus k2 multiplied by u2 plus k2 multiplied by u3 equal to f3. Hence, u1 does not appear there, that really means coefficient of u1 is 0, and hence we can write coefficient of u1 as equal to excuse me, I think we have done already this one. last line we have done already. Okay, sorry. So I was okay. So we wanted to do the middle one, okay, and hence the then we have to go back. We have to see the okay, just a minute. So go back here. So what we wanted to know now is not the last row, not the where the force is F3, rather we want to know what is the coefficient of U3 in the middle row, yeah, in the middle row. Okay. So okay, so let us go back. So we have we have two of them, this one multiplied by this and this one multiplied by this one, okay, and we are adding them together is equal to F21 plus F22, and hence how we are going to do, the coefficient of U1 is minus K1 and coefficient of U2 is K1. In this case, coefficient of U2 is K2, coefficient of U3 is minus K2. So what we see here is coefficient of U3 is minus K2. So sorry about the confusion actually. So I should be working for the second row. However, I was for some time I was talking about the last row, which I had done already. So here this one should be minus K2, minus K2. Why? Because minus K2, the coefficient of U3, we are now concentrating on these two equations only, this multiply with this and this multiply by this, and which we are adding, and coefficient of U1 is minus K1, coefficient of U2 is K1. In this case, coefficient of U2 is K2, coefficient of U3 is minus K2, hence we wrote minus K2 there. Now coefficient of U2, if we multiply this times this, then obviously the coefficient of U2 is K1, and if we multiply by this one, so coefficient of U2 is K2. So what we say, from here we get K1 and from here we get K2. So we are adding them together, hence it will be K1 U2 plus K2 U2, that really means K1 plus K2, that is what we get. Yeah. So that really means we have to write here, in this case it will be K1 plus K2. Okay. So this is what we call it the assembly. This we can write it as F1, F2 and F3, and where F2 is nothing but F21 plus F22, yeah, like this. Yeah. So what we have? We have K1 minus K1 minus K1 0, minus K1, K1 plus K2 minus K2 0 minus K2, K2 multiplied by U1, U2, U3 is equal to F1, F2, F3, where F2 equal to F21 plus F22. You are combining the two into one, right? Okay, so this is what is known as assembly, yeah, assembly of the stiffness matrix, assembly of the stiffness matrix, this one. We have assembled them together. Yeah. So what you can also notice is K1 minus K1 minus K1 and K1. This is coming from the first element. So this is coming from, this one is coming from the first element, and then then you have K2, right, and then minus K2 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 minus K2 minus K2 K2, this is coming from the second element, yeah, and the middle one where K1 and K2 is being added, that corresponds to the middle point basically, yeah. So what I mean to say is, if you look at the springs, we have like this one, 1 2 3. So first we have K1 minus K2 minus K1 minus K1 you have that, and then you are going to add K2 minus K2 minus K2 K2, and then you are going to multiply it by U1 U2 U3 equal to F1 F2 F3. Okay. So basically this is how we assemble, and we can straight away we could have assembled instead of writing the equation. We can now since we know, we have worked out, we know how it works, so we can now straight away assemble for this one. And how? Let us say this is U1, this is U2, this is U3, yeah, and then you have F1 here, then we write F2 here, and then write F3 here, and then we have the displacement vector U is equal to U1 U2 U3, and then you have a force vector F equal to F1 F2 and F3, and then you have a stiffness matrix K, and the relationship is K times U equal to F, where K is equal to, we can assemble, and how we can assemble? We can do like this. So we have 1 and 2, and then so the first one has, we know that if this is a K1 here, this is K2 here, so we can write the global numbering. So 1 2 3, here also 1 2 3, right, okay, and then we can have, like if you go back and if you see your stiffness matrices here, you had for the first one you had K1 minus K1 minus K1 K1, which corresponds to node 1 and 2. So you can say this is K11, this is K12, K21, K22, right, yeah. So basically we can straight away we can write, so K11 is K1 here. Now K12 is minus K1, K21 is minus K1, and K22 is K1. Okay, now we will move to the second one. Again we have K11. For this one we will have this plus, now the second one starts K2 minus K2 minus K2 K2, whatever is not filled will be equal to 0. Okay. Okay. What I mean to say, I am going to explain again. Okay. So what we mean to say is how we assemble. So let's say we have one spring here, and the stiffness matrix because of that will be, if the local numbering is 1 2, so we will have k is equal to k11, k12, k21, k22, which is equal to k minus k minus k and k. Let us say that this is the local numbering, the global where, let us say the global was global number was 5 here and 7 here. Then how to assemble? Then this is a small k. For big K, we have to look for number 5 and 7. So, look for 5, there will be 6, there will be 7, let us say 7 here, there will be more 4 and 4, 5, 6, 7. Now, you have to relate number 1 is number 5, right. So, 1 is 5, right. So, in that case you basically write here this is 5, because 1 corresponds to 5, so you write 5 here, 2 corresponds to 2 local corresponds to global 7, you write 7 here, and here also 5, here also 7. So, what you see here K55, see here K55, this one you have to write here, and that really means you have to write from here. If you look at K55 becomes K here, and then K57, because minus K, so you write minus K here, then K75 is this minus the K75 is this, that is minus K. So, we write minus K here, where 7 and 5 same as this 7 and 5, right. And then you have 7 7. So, this is 7th, this is 7th, 7th row, 7th column. So, here also 7th row, 7th column, here you have to write K. Okay. So, other places we do not know what it is, but this is how you have transferred from local to global. Yeah. So, you have a stiffness matrix which has written in, you are writing this in global, in local. So, you have a, you have local numbering here. So, local numbering is 1 and 2, 1 and 2, and here you have global numbering 5 7. So, 1 corresponds to 5 and 2 corresponds to 7, and this is how you are transferring here to this one. Yeah. So, from local to global. Same thing actually we have done here. This one from here to here is for the first one, and this one from the second one, and we, since K1 comes here and K2 also comes here, so you have to add them together, hence you have added. Yeah. And that is it, that is how you make it, and hence how the value of this big K you will get same as how you got it here. This we got by working it out, meaning that we expanded the equation, we added 2 equations. So, total 4 equations we had, now we reduced that to 3 equations by adding 2, the equation number 2 and 3 we added together to get the middle equation here. But no need to do this, meaning that if we know the stiffness matrix for one of them, then we can directly assemble like this one. Yeah. So that's what we have done here. Okay. So this was the method you will follow to do it. From local to global you are doing it. Okay. Now once we know that, then we can solve the problem. So let us say, let's see one example now. So let us say we have a problem to solve. Let us say there are two springs. We have a spring number like this one. There are two springs. Yeah. We have a force. We are applying by 3 Newton here, and then let us say it's called it's a 3 Newton force given, and stiffness is also given in this case. Let us say this is 2 Newton per meter and this is 1 Newton per meter, the other one, and then we have to find out all the values. Okay. So first what we do, we will write, this is 1. Always you start with the node numbering, say node number 1, 2 and then 3. Then you see which all things are given. So u1 is equal to 0 because it's fixed, right. u2 equal to what we have to find out, and u3 equal to what we have to find out. Then f1 we don't know, either you know the displacement or the force, you cannot know the both of them. You have to, what is meaning, what is the meaning is here, either you prescribe u or a, means u1 you are you have given, so you cannot give f1 you have to find out. Okay. Now the second case, f3 equal to 0, sorry, f2 equal to 0, because you have not applied any force here, so f2 equal to 0, and then we have f3, so f3 equal to 3 Newton. Okay, because you have applied 3 Newton here. Okay. So now we have to solve now. So but before that we have to assemble. Okay. How to assemble? Okay. So local for k1, 1 for the first element really means k1 is equal to, this is the stiffness matrix for the first element, which will be equal to 2 minus 2 minus 2 2, right. Okay. And k2 means a stiffness matrix, this element number 1, this element number 2. For stiffness matrix, because of the second element will be equal to 1 minus 1 minus 1 1, like this. Yeah. Now we have to assemble, and how do we assemble? We have to see the local and global thing. Yeah. So how do you do that? Okay, just a minute. So remember, this is node number 2, not 1. So 2 here. Yeah. Okay. So how to do that? We are going to write global node number. So see here, this is 1 and 2. Local also, in global also this is 1 and 2. So this retains whatever. So we have 1, we will have 1, 2 and 1 and 2. Okay. Now for this one, local number is 1 here and 2 here, but global number is 2 here and 3 here. So 1 becomes 2, 2 becomes 3. So we can write it as this is 2, 3 and 2 and 3, like this. Yeah. And now we can assemble. How? We have 1 1, for example, k11 he is here, k12 is here, right, k21 is here, k22 is here, and then we can assemble them together. Yeah. So we can write k, big K, let us write big K. Okay. I am going to write big K here. Okay. So in the corner. So if you want to write big K is equal to, and here we write like that. Okay. and you can have 1, 2, 3, similarly 1, 2, 3, these are the global numbering. Now let us see here, K11 is 2 actually, right. So, K11 is 2. So, we are going to write 2 here, right. Then we have K12 is minus 2, K12 minus 2. Then K21 is minus 2. So, K21 minus 2. So, minus 2. K22 is 2. K22 is 2. So, we write 2 here. Now, we have completed K1 now. Now, let us move to K2. We have K2, 2 is 1. So, K2 is 1. So, we have to add 1 here because already one thing is existing there. Okay. Now, we have K2, 3 is minus 1. So, K2, 3 is minus 1. So, here and minus 1. K3, 2 is minus 1. Yeah. So, K3, 2, this one is minus 1. So, we write minus 1 here. Okay. K3, 3 is 1, this one. So, K3 and 3, this one is 1. So, we are going to write 1 here. Okay. So, we have completed all of these two already. So, wherever you see blank, that means it is 0 there. Okay. So, we will write 0 here and 0 here. Okay. So, we have assembled it, and simply what we get is, we get K equal to 2 minus 2 0 minus 2 3 minus 1 0 minus 1 1 like this. Yeah. So, all of them is Newton per meter only. Okay. So, typically we do not write any in computer, for example, there is no units as such, meaning that your inputs are according to your unit system. Okay. However, here the problems, whenever there is unit given, it is good to give the units as well. So, you have this stiffness matrix for your problem. Okay. Okay. And now you have to assemble displacement vector. So, you have 0, u2, u3 will be the displacement vector, and the force vector will be F1, 0, 3. F1, 0, 3, because here we do not know what is the force. So, we have to find out. So, F1, 0, 3 is the displacement, and 0, u2, u3 is the displacement, and F1, F1, 0, 3 is the force vector. Okay. So, let us write that. So, our equation is basically the K, so far what we get is equal to, if you look at here, we get 2 minus 2 0 and so on, 2 minus 2 0, then minus 2 3, then we have minus 1, then we have 0, minus 1 1, this is the K. Okay. And then we have the force vector F, we do not know what it is. The first one F1, second 0, and last one is 3 Newton. U vector, you have first one is fixed, second one you do not know, third one also you do not know, we have to find out, and your equation is this multiplied by this equal to this, and your equation is 2 minus 2 minus 2 3 minus 1 minus 1 1 0 0 multiplied by 0 u2 u3 is equal to, you have f1 0 3. This is what the equation is. Okay, and this you have to solve this one. Yeah. Okay. So now how to solve? What you see here, what we will see here is there is a 0 here. So this 0 this multiplies to this one, this 0 multiplies to this, and this 0 multiplies to g. So that makes it 0. Yeah. So automatically this there is no use of this column, because this 0 will multiply to that and then there is no use. So what we will do is we will strike it out. Yeah. So we do not need this one. Yeah. Okay. And also in order to solve the first row we do not need it. So the first column and first row we do not need it, because why? Because f1 is there which is unknown, right, and because of that we do not want to that equation yet. So what we needed, just this multiplied by this equal to this is the equation, means second and third equation we are going to solve, and we know that in both the equations coefficient of u1, since u1 is 0, it is going to multiply to this one, hence it has no meaning. So we can actually write equation 2 and 3 as follows. We can write minus 1 we write 3 minus 1 minus 1 1 multiplied by u2 u3 is equal to 0 3. So this is now if you want to know what is u2 and u3, you can just invert the matrix, you get it. So u2 u3 equal to 3 minus 1 minus 1 1 inverse of that multiplied by 0 3. So this is your answer. Okay. So let us finally find out. So 3 minus 1 minus 1 1 and 0 3. So you have u2 u3 is equal to 3 minus 1 minus 1 1 inverse of that and 0 3. Okay. So how will you invert? So in 3 minus 1 minus 1 1 inverse of that will be you are going to interchange this, and this can be interchanged. Okay. So this is how you invert, right. So you may have your own methods. So this is how you do. This is 1 and 3, and then the sign will be changed in this case. So you have 1 and 1, right, and then you have to divide by the determinant. So you have 3 multiplied by 1 minus 1, so becomes 2. Determinant is 2. So, this one, and you have 0 3. So, this is equal to what we get, half, and then you have 0. So, this multiplied by this, so 0 multiplies to 1, and then you have 3. So, you get you have 3 here, and then again 1 3 multiplied by this one. So, 3 multiplied by 3, you have a 9 here. So, you get 9 here, okay, like this, yeah, and is equal to 1.5, and you have 4.5. Okay. So, this is what your answer is. This will be in meters, yeah. Okay. So, this one is that means U2 equal to 1.5 meter and U3 is equal to 4.5 meter. Okay. Once you know that, you can also find out now the forces, and for that you can use the first equation now, right. So, first equation relates U2 U3 to F1. So, what minus 2 times U2 plus 0 times U3 equal to F1, or that means F1 equal to simply minus 2 times U2, that is what it means. F1 equal to minus 2 times U2, right. So, we can go back, we can find out minus 2 times U2 equal to F1. Okay. So, let us write here. So, F2 F1 equal to minus 2 times U2 is the F1, and is equal to minus 2 multiplied by U2, and U2 is 1.5, and you write 1.5 and you get minus 3. What you see is F1 equal to minus 3 Newton, and you should get F1 equal to minus 3 if your answers are correct. Why? Because if you are applying a force of 3 Newton here, automatically you know by physics, by the third law of motion also. So, if a reaction is equal and opposite, so opposite is this direction, hence minus, and equal 3 Newton here. So, there should be 3 Newton here, yeah. So, you should have here 3 Newton, right, yeah. Automatically you got by calculating, you are not actually applying the physics here, but you are getting answer automatically. So, this also shows that your answer is correct, because means whatever you got, the U2 and U1 is correct basically, yeah. Okay. So, this is how you solve the problems, yeah. So, we have got U2, U3, and you have also got F1 because of that, and all the unknowns are known now, yeah. So, this is how you use finite element formulation for the this direct method, direct approach, yeah. So, there we did not solve any differential equation, but rather a system which had some input, some output, or we can think in that way, or we can also think in terms of there is something nodal value. So, like U1 and U2, difference of that, right, U2 minus U1 multiplied by k is some some property which is force or tensile force inside that. So, these kind of equations can be solved using like that. Yeah. You can extend that to many other kinds of problems, which I will discuss later. Okay, that is all for now.